Um, Good afternoon. Today we'll be discussing about the matrix refraction. And we all know what a matrix is. A matrix basically is a collection of elements into a rectangular array. And why refraction basically is when light ray changes its direction when it travels through a medium. And basically these two words, matrix and refractions, are different, but here we're trying to see how we can correlate and relate these two words together. And first of all, we are going to be looking at the matrix refraction of a spherical surface. And let's assume this is a spherical surface, and this is a point, and a principal axis that runs through the pool of the spherical surface. Now, what this is called is the principal axis, which is an imaginary line that runs from a point through the pool to a point, and let's assume an object is placed here. An ray of light travels from this point and hits the curved surface at this point. We can call this point A and we can call this point B. Now, if this is a spherical surface and this is a principal axis, now on the principal axis at point A, now a ray of light travels from this point A to the spherical surface at point B. Now when it hits this surface, now let's assume there's an imaginary line that runs through B here. Therefore, we can now say that there is an imaginary normal that cuts across B and also at the principal axis at C. Now this C is known as the center of curvature of the spherical surface. Now we all know from the knowledge of refraction that when a ray of light travels from a less dense medium to a more dense medium, it changes its direction towards the normal. So now this ray of light that travels from point A to point B, when it reaches this point, it refracts. Now, since the spherical surface is more dense than this medium, as the case may be, it tends to travel away from the normal. Because this is the normal, it tends to travel away from it. So, so this forms an angle with this imaginary line, which we call μ, and this forms an angle μ1, and this forms an angle μ2, and this forms an angle μ. Yeah, so now the total of this angle gives us the angle of incidence, and the total of this angle gives us the angle of refraction. Now we all know that there's a height formed here, and also there's a height formed here, such that we can call here y1 and we can call here y2. Let me write it here well, y1. Yes, so what I mean is this. Now when this ray travels from this point and hits this spherical surface, at point B, now it refracts towards this direction, and when it changes its direction, it forms an angle mu 2. So it means it forms the height from this principal axis to this point of incidence is y1, and the height at which it leaves the spherical surface away when it refracts away is forms a height y2. So in that case, we all know that y1 is equal to y2. This is very important. Now, if we recall from Snell's law that the ratio of sine of angle of incidence over the ratio of sine of angle of refraction is equal to mu 2 mu 1. We can call this equation 1. Now this equation 1 can be written as sine I over sine the angle of refraction mu 2 over mu 1, which we can call equation 1, 2, right? But they are the same equation actually, but I just want to rewrite equation 1 in another form. So therefore, we now know that the angle of incidence is the sum of the angle of mu plus mu 1, and the angle of refraction is the sum of mu plus mu 2. So now when we substitute it into the equation 2, we have sine mu plus mu 1 over sine mu plus mu 2, which equal to mu 2 over mu 1. Now, now when we recall the parallel approximation, that is sine mu plus mu 1 is approximately the same as mu plus mu 1, and sine mu plus mu 2 is approximately the same as mu plus mu 2. So now when we substitute into this equation here, we have mu plus mu 1 over mu plus mu 2, which is the same as mu 2 over mu 1. Then we cross multiply. We have theta 1 mu 1 theta 1 plus mu 1 theta 1 is equals to mu 2 theta plus mu 2 theta 2. So now let lambda 1 be equal to mu 1 theta 1, and let theta 2 be equal to mu 2 theta 2. Therefore, mu 1 plus mu 1 theta 1 is equal to theta 2 plus mu 2 theta 2. Then we can now continue. We make we make that lambda we make lambda to the subject of the formula. Then we have mu1 theta 1 minus mu2 theta 2 plus lambda 1. So now recall from the paradoxal approximation that theta 1 is approximately the same as theta 2 and is approximately the same as theta. So mu2 is the same as mu1 minus mu2 theta plus lambda 1. So now if you recall from this, we all know that this is the height, which is the same as this height, and the distance from the pole to the center of curvature is r, and this angle forms theta because they are alternate to each other, as you can see here. Therefore, we can now draw something like this: y1, which is the same as y2, yes, which is the same thing as r. Then here is theta. So we can now know that tan theta is the same as y1 over r. Now, from the paradoxal approximation, tan theta is the same as theta. Therefore, lambda 2 is the same as mu1 minus mu2 over r. Then what's y1 plus lambda 1, where this whole is represented by p is equals to mu1 minus mu2 over r, and it's known as the refracting power of this lens, spherical surface. The refracting power of this lens is known as p is equals to mu1 minus mu2 over r. So it's just like taking the difference of the refractive index mu1, mu2, and when you take the difference, then you now divide it by the radius of curvature you have here to get the refractive power of this lens. Then we can now represent what we got, where this we can call equation star. Then we can rewrite it as lambda 2 is equals to lambda 1 plus mu1 minus mu2 over r y1. We can now rewrite this as y2, y1, the coefficient of 1, plus lambda 1, the coefficient of 0. We can now rewrite this in matrix form as lambda 2 y2, which is equal to lambda 1 y1. Then the coefficient of y1 here is 1. The coefficient of y1 here is 0, and the coefficient of y here is sorry, we are going to write it as y2 respect to lambda 2, which is the same as 1, then with refractive power, then mu1 minus mu2 over r. Then here we have 0 and the coefficient of this is 1, which is y1 more 1, then y1 more 2. So now this whole is known as the matrix refraction. And my mistake, I made a mistake here. I instead of writing this, which is y2 before this, which is supposed to be the representation of my matrix here, which is the rectangular array. So that was the reason why I cancelled it. Thank you.